This is the first lecture for homework 3.2, starting with question 1. Find the domain of the relation S given below. Now, you'll notice that this set is comprised of 5 points. Each point has an x-coordinate and a y-coordinate. You'll also notice that it says for help with number 1, see 3.2 example 1. If we look at 3.2 example 1, we'll see a very similar problem. And the domain is found by identifying the x-coordinates of each of these points. So 2, 3, 4, 5, and 6, being the x values, are the domain listed out as a set. Likewise, if we list out these x-coordinates, negative 18, negative 13, 13, 7, and 0, we have the domain of this set. Now, it's a lot trickier if you're looking at an equation, because you have to figure out which values of x can be included in the function. In the case of a rational function, one that has a denominator, what we're concerned about are zeros in the denominator. So any value that could cause the denominator to equal 0 would be a problem for this function. In other words, 15x minus 23 cannot equal 0. Otherwise, we would have a 0 in the denominator. So if we add 23 to both sides and divide by 15, we end up with x cannot equal 23 over 15. Now, what we have here is 1.5333. Do not enter a decimal, even if my open math shows a decimal. What you want to do instead is enter the exact value. And so in this case, we would say 23 over 15. This is saying that the domain is all real numbers except this one value. Now, if I enter this, I am given a correct answer by entering the fraction. The purpose of the decimal is the decimal by which you are checked for the fraction. Sometimes the way it's coded, it's not going to show up as a fraction, but nonetheless, for your answers, whenever they can be exact, you do need to give them as exact answers. Okay, so now we have another situation where we're looking at the denominator and we don't want it to equal 0. So if we set the denominator equal to 0, knowing that we don't want it to equal 0, we set it equal to the 0 anyway, and then we solve using the zero product property, then what we have are two values which, if we plugged in either negative 10 or 5 into the denominator, we'd end up making the denominator 0. So we don't want these values. Now notice that's what the second option is. It's saying every value of x is fine in the domain except negative 10 and 5. So that's what this set notation is trying to communicate. The way it's read is x such that, that's the vertical line, x cannot equal negative 10 and x cannot equal 5, but any other value of x is fine for the domain. So in general, what we have are for functions, you can assume that all real numbers are allowed unless you see one of these red flags of a denominator, which cannot equal 0, or an even root. So here we have a square root. Now, unless we're dealing with imaginary numbers, we're not allowed to have the square root of a negative number. That's another way of saying that what's inside the root needs to be non-negative. So we would say then that 3x minus 8 needs to be greater than or equal to 0. And if we solve this inequality, we end up with x is greater than or equal to 8/3. Now, I don't want to put that inequality in here. Look at the directions. It says use two lowercase zeros for infinity. That tells me that what I actually need is an interval notation. So I want to go from 8/3 to infinity. So let me type that in. I'm going to do 8/3, comma, infinity. Now I could put the two zeros in, but there's also the infinity button here, so I'm just going to do that. Infinity always takes a parentheses, never a bracket, and so now I'm going to submit that question. Next, we have various examples matching set notation to intervals. I would say just pop over to the book, look at figure 5, and in figure 5, you can see here that we have a variety of different scenarios presented. What would it look like as a graph? What would it look like in set builder notation? What would it look like in interval notation? And you can match those up. Now let's talk about how to determine the domain and range graphically. The domain graphically is going to be all the possible x values that you're going to see on the graph, and the y values would be the range. So notice that as far to the left as you can go here on this graph is -5 because it stops with a solid graph. But if we follow the graph, it goes on forever as we go to the right, which means the domain starts at -5, but then it goes to positive infinity. The range, on the other hand, has its highest value at 5, and then it goes down to -infinity. So the range is going to start at +5 and go to -infinity. Of course, that's an interval that's written the other way around, going from -infinity to 5. When we look at this graph here, we want to be really careful about the variables. So notice if you zoom in, you'll be able to see a D and an F. This tells us that the D is your domain variable and the F is your range variable. So as we look at the possible values on this horizontal axis, the D axis, we see that as far to the left as you can go is 2, and as far to the right that you can go is 7. We're just looking at those x coordinates, or in this case, D coordinates. On the vertical axis, we have a value of 7, and we're going from 7 up to 14. So it may be even helpful to look at this as a triangle, that the base of this triangle is representing the x values going back and forth between 2 and 7. And then this up and down leg here is representing 7 to 14. These are the possible y values. So then when you're looking at your answers, you do need to pay attention to the fact that this question is about the domain, not the range. And so you would only want to pick a value with a D. And we already said that it went from 2 to 7, and so we would end up selecting the second answer. In this question, we're looking at the range only. The range is represented by the letter C. It's a little hard to see that, but here it is, the letter C. The highest value for C is 7, the lowest value is 0, so the range here is going from 0 to 7. And so we would want to make sure we pick this last option, not the first option. The first option is giving you a G variable. We want the C variable. Here now for number 10, we are given a graph, and we are to write the domain and the range, written in both interval notation and set builder notation. So first of all, for the domain, we can see that we're going from -3 to +4 as your possible x values, but we don't want to include -3 because of the open circle. We do want to include +4 because of the closed circle. So when we write that, we would want to represent that as parentheses, -3, comma, +4, bracket, to show that I'm going from -3 to +4 on this function. The corresponding set builder notation is going to represent this as an inequality. So we would want to say that we're going from -3, not including -3, to +4, including +4, and we would represent the interval as an inequality. The rest of the set builder notation is already written out for you. You have the braces on either side, and then the x such that, also included for you, and you only need to fill in the inequality. For the range, we're going from 4 to 5. You can see it right here. We're starting at 4, going up to 5, not including 4, but including 5 because of the solid dot. And so we would represent this one going from 4 to 5. And notice I don't use an x here, I'm using a y here, because we're looking at range. Okay.